Hello, my name is David Cho, and I am a math tutor here at 튜터하이브, and I'm here today to provide a demo class on my math lesson. I picked this AP question from AP Calculus May 2023. It was taken from AB Section 2 in Part B, so we'll get into that. Okay, here we have AP Calculus AB question from Section 2, Part B, meaning we need to provide a free response, giving some reasons and justifications, not just the answers, and we are not allowed to use our calculator here. So number 4, the function f is defined on the closed interval between -2 and 8 and satisfies that f of 2 is 1. The graph of f prime, the derivative of f, consists of 2 line segments and a semicircle as shown in the figure. So the graph here at the top is our graph of f prime. Question like this appears a lot on AP. I think in 2022 we saw a question like this as well. So it's good that we're covering these topics. So diving into part A. Does f have a relative minimum, a relative maximum, or neither at x equals 6? And give a reason for your answer. So what happens? When do we have our relative minimum or relative maximum? Relative minimum will have will be a point like this, and this would be like our relative maximum. So when does it happen? It happens when our slope sign, so the sign of our f prime changes. When we have a relative minimum, relative. When we have a relative minimum, our sign of f prime goes from negative to positive at this point. And when we have a maximum of relative point, the sign goes from positive to negative. So we are looking for a point like that. And at 6, x equals 6 is the point of interest. And looking at the left side of this point, so from our open interval between 2 and 6, we can see that our f prime is bigger than equal to, well, actually, bigger than 0. And on the right side of this point, where x is 6, between interval 6 and 8, our f prime is also positive. So we can see that between the left side and the right side of 6, the sign of f prime does not change. So we conclude that this point is neither a relative minimum or a relative maximum. So I will not write down my reasoning in the interest of time, but in the actual exam setting, you will not only just provide the answer, but we will have provide the reasons why you think it's neither. Part B. On what open intervals, if any, is the graph of f concave down? Again, give a reason for your answer. So concave down, we have a negative concavity, meaning we're going to have a graph like this, where it's like graph down. And a characteristic of that is that f double prime is negative. In other words, that means our slope, so what's our f double prime? It's a derivative of our f single prime, right? So it's a slope on f prime graph, which we have on the right, is, so when do we have that? We have that in this section. You can see between -2 and 0, our slope of f prime is negative. It's like decreasing. Decreasing is another way of putting it. Decreasing. So if we find the derivative of this, our f double prime will be negative because f double prime is a slope of that. Another section would be here, between 4 and 6. You can also see here that it's a decreasing section. So we have 2 intervals between -2 and 0, and between 4 and 6, we will have f being concave down. Part C, find the value of this limit. We have a rational expression here. find the value of this limit as x is approaching 2, or show that it does not exist and justify your answer. So let's look at this limit of this rational expression. First of all, we want to find the limit of f of x as x is approaching 2. So in the question, we are given that f of 2 is 1, and based on the graph above, this point here, we can see that f is differentiable at x equals 2. So what we can conclude from that is that f is differentiable at x equals 2. That means f is also continuous at x equals 2. Then, because f of 2 is 1, we can conclude that our limit of f of x is also 1. So plugging that into our rational expression, our numerical limit becomes 6 times 1 minus 3 times 2, which is 0. And looking at our limit of the denominator, we have x squared minus 5x plus 6. This, by plugging in 2 into x, we also get 0. So this limit, we have an indeterminate form. Indeterminate form of 0 over 0. And in this case, what do we use? We use our L'Hopital's rule, which states that the limit of such indeterminate form can be found by finding the derivative of both numerator and denominator and finding the limit of that. So derivative of our numerator is 6f prime x minus 3. And then derivative of our denominator here is 2x minus 5. So using the L'Hopital's rule, we can state that this overall limit, I'm kind of running out of space, but this overall limit is limit of this new expression over 2x5 as x is approaching 2. Now we can plug in numbers. F prime of 2 here is 0. So this will be minus 3 over 2x minus 5. By plugging in 2, we get negative 1. So this becomes 3, and that becomes our final answer. D, find the absolute minimum value of f on the closed interval between -2 and 8 and justify your answer. So we are interested in the absolute minimum value. And the possible candidates for these points is our endpoints, which is, so let's list our possible candidates. Candidates is when our x is endpoints, so like -2 and 8, and all the relative maximum or minimums, or possibly relative maximum or minimums in between, which is when our f prime is 0. So when is our f prime 0? That will be here -1, 2, and 6. So -1 and 2 and 6 also becomes our possible candidates. And from part A, we can eliminate 6 as a candidate because in A, we proved that this 0.6 is neither relative minimum or relative maximum. So it cannot be an absolute minimum. So 6 we're going to get rid of. And so we have f of 2 value already. F of 2. And looking at point 8, so going from point 2 to point 8, we can see that within this interval, our f of prime is always non-negative, right? It's either positive or 0 when it's at 6, meaning that going from, when we have a graph of f, whatever that may be, going from the point of 2 to 8, this value of f is always going to be increasing or just staying, like, remaining the same at 0.6. So it's always going to be increasing, or it's never going to be decreasing. That's a more correct way of saying it. So that will never be the absolute minimum, because f of 8 will be bigger than f of 2. So we also eliminate f of 8, or 8 as a possible candidate. So let's look at, so we are starting with, so we are left with 3 possible candidates, x being -2, -1, and 2, and our f of x. F of 2 is given in the question as 1, and our f of -1 can be found by finding the definite integral. So going from -1 to 2, our f of x is this area, right? This shaded area. And using the area of triangle, our base is 3 and our height is 2, so we have -3. So what that means is that going from the point where x is -1 to where x is 2, our change is -3, right? So that means our f of -1 will be 4, because this change is the value that we just found. This is the difference between these f of x's. And going from, we can use a similar method from -2 to -1. This area is 1, so going from -2 to -1, our f of x, sorry, I should have said f prime of x is 1. So that means going from -2 to -1, this f of x increased by 1. So that will be 3. So now we have 3 possible candidates for absolute minimum value, and we have their function values as well. And out of these 3, 1 is the smallest value. So we conclude that our minimum value, absolute minimum value of f is 1. And this happens when x is 2. But the answer is 1, because we're looking for the absolute minimum value, not the point of x when absolute minimum value occurs. So that concludes our AP question. All right, so that wraps up our demo class. I wish I had time to cover other topics and one from IB exam as well, but in the interest of time, this is it. But if you have any issue with your math class and need some support and help, I'm always here, and feel free to reach out. Thank you.